Hey everyone, this is a problem that we often do in calculus classes, so it's good to approach how to set this up in order to apply it in calculus later. So let's see, there's lots of words here, so let's take our time. It says a man in a rowboat that is 3 miles from shore so this distance is 3 miles from shore to a point A, so perpendicular to the shore. Okay, would be the shortest distance to the shore. On a straight shoreline, wishes to reach a house that's located at point B, capital B, that is 6 miles farther down the shoreline. So this distance is the 6 miles. So from here to here, okay? Straight line distance. And then you know the distance between the point P and the point B. So he could row to P, and then he could, in this case I think he is rowing and then walking. Okay, so he could walk from P to B, and that would be a distance of X miles. Okay, so this is perpendicular to the shoreline. We know that this distance A is 3 miles. So that would lend itself to our being able to conclude that the hypotenuse, which is the distance from the bow of the boat to the point P, would be determined by the Pythagorean theorem. Okay? And also that if the entire distance is 6 miles and from P to B is X miles, then from A to P would be 6 minus X miles. So let's look at it like this. So we have A, P, B. So this was X. This whole thing is 6 miles. So this would have to be 6 minus X miles. Hope that makes sense to everyone. Okay, now likewise in the right triangle made from the boat, so here's the boat, to the point A on the shore, presuming he is rowing to the point P, would have one leg 6 minus X and one leg the given 3 miles. So if you apply the Pythagorean theorem to get from the boat to P, then this distance will be the square root of the sum of the squares of the other 2 legs. So again, that's from the Pythagorean theorem. Okay, so hypotenuse squared is 3 squared plus 6 minus X squared, and then you solve for the hypotenuse. So these are the things that we know. Now what's the ultimate goal of this problem? It says, suppose he can row 3 miles per hour and he can walk 7 miles per hour. If capital T is the total time required to reach the house, express the total time as a function of X. And one thing we may have to go back and just think about for a moment is that distance traveled is rate times time. So if I know the distance traveled and I know the rate, then I would have the time traveled. Okay, so my time, capital T, would be the time he spends rowing plus the time he spends walking, which would then be the distance rowed divided by his rowing rate rowing speed, plus the distance walked divided by his walking rate or speed. Okay, and that would give us time elapsed. So again, now time is in this case going to be in hours because both of my rates are given in hours. The distances are in miles. Okay, so when I say the distance rowed, that's this guy right here, this hypotenuse, which we determined was 9 plus 6 minus x quantity squared, okay, from over here. Okay, so the distance that he's been rowing in miles divided by the fact that he can row 3 miles per hour. Notice that when we invert and multiply the units, the miles would cancel and we will have hours. So that's something you do need to check. The distance he walks is x miles. His walking rate is 7 miles per hour. So we see that the time elapsed in hours would be the square root of 9 plus 6 minus x quantity squared divided by 3 plus x divided by 7, and all of this will be in miles. Excuse me, not miles, hours. We already discussed that. Okay, apologize. Will be in hours. Okay, so again, notice miles per hour in the denominator means when you invert and multiply, you're left with hours in the numerator. Okay, so I hope this makes sense. And again, we often use this in calculus to do something further, which would be to minimize the time, total time spent traveled in this situation. Okay, so the setup is crucial. So hopefully this makes sense.